What's up guys, here Mr. G with another video about stoichiometric. Very important topic for all the grades 10, 11 and 12, and this time we're going to be determining the limiting reagent. And then when we determine the limiting reagent, we are going to find out the theoretical yield. In actual fact, you cannot find out the theoretical yield if you do not have the limiting reagent. Okay, so now this question say 198.6 gram of lead 2 nitrate react with 4.5 cubic decimeter of a 0.2 mole per decimeter cubic solution of sodium hydroxide. The reaction is, and then you see the reaction, determine the limiting reagent. Now, to determine the limiting reagent, the first thing you are going to do, this one is equation A. Step 1 is to calculate the number of mole. Calculate the number of moles of each reactant. Alright, so we are going to calculate the number of mole of each reactant. We have two reactants here, which in this case is going to be PB, NO3 bracket, NO32, and the other reactant we have is NaOH. I'm going to do separated and I'm going to write the data we have here. We know, for instance, for lead 2 nitrate, we have the mass in grams. So for this one here, for lead 2 nitrate, we have mass in grams, which is equal to 198.6 grams. That's all we have. And then for the sodium hydroxide, we have a little bit more information. For the sodium hydroxide, if you go there, you have the volume. You have the volume there of the solution, that is the volume of the solution, be careful, and then we have the concentration of a solution. I say be careful because people attempt to confuse this one only for gases all the time. So for this one we have the volume of this specific solution, which was 4.5 cubic decimeters, and we have the concentration of that one, which is 0.2 mole per cubic decimeters. All right, now in each case we have to calculate the number of mole. It doesn't matter what formula you use to calculate the number of mole. So in this case, because we have the mass, the best way is to say that number of mole is equal to mass divided by molar mass of lead 2 nitrate. And when you do that, the first thing you obviously need the molar mass of lead 2 nitrate. That we can do it real fast. Let's do it, even though I'm sure you can do it, but let's do that one there. So molar mass for lead 2 nitrate, everything that is on this side is for lead 2 nitrate, will be equal to 207. Remember to go to the periodic table, plus 2. These 2 here outside the bracket affect everything inside. So that 2 is for the nitrogen as well as for the oxygen, which in this case you have 3, so it's 6 oxygen. All right, so nitrogen you have 2 times the mass of nitrogen, which is 14, and then plus 6 is 3 times 2 is 6 oxygen, which is 16. When you do this one, you will get that the molar mass of lead 2 nitrate is 331 grams per mole. Okay, and this one is needed, obvious, for this calculation of mass. Now we have here that this 198 grams divided by 331, and then the answer is 0.6 mole for lead 2 nitrate. Now we are going to do the same for sodium hydroxide, but do a different formula because we don't have the mass. What we have here is the concentration and the volume. We're looking for the number of mole, guys. Number of mole, or let's say concentration, is equal to number of mole divided by volume. all we have to do is to substitute all the information, all the data is in the units they must be. So the concentration is 0,2, the number of mole we are looking for that, and the volume is 4,5. When you do solve this one, you get that the number of mole is going to be equal to 0,9 mole. So we have now the number of mole. But guys, note the following. The fact that the number of mole of sodium hydroxide is less than the number of, is more than the number of mole of the lead 2 nitrate doesn't mean that the lead 2 nitrate is the limiting reagent. So we still have to go now to the ratio. So step 2, I am going to write just ratio between reactants. Alright, and we are going to do the same. So we are going to do the following. We are going to look for the ratio of lead 2 nitrate, Pb, to sodium hydroxide, and we are going to do it on both sides. I'm going to show you just now. Or you could have the same ratio, Pb bracket NO32 to NaOH. You can use either one, okay? So when you go to the period, to the equation here, the ratios, remember, are the numbers at the front. These numbers here, which in this case is 1. Oh, that number is not good. Let's do it like this. 1 and 2, those numbers are the ratio. Okay, so we go big, is 1 is to 2. So we go back here and we have 1 is to 2, 1 is to 2. So all I'm going to do is to substitute either of the moles. It depends which option you like. So if we go here for lead, we said if we have 0,6 mole of lead, how much of the sodium hydroxide will I need? And guys, you do cross product here. So if you do this one, you will get that the number of mole of sodium hydroxide needed is going to be equal to 1,2 mole. How much do you have at the beginning? You only have 0,9. So you do not have enough sodium hydroxide. So it means that the sodium hydroxide is the limiting reagent, because we need more than the amount we have, and the lead 2 nitrate is the excess reagent. That's all using this method. That was to identify. If you use the other way here, it's the same thing, and you say, all right, if we have 0,9 mole of sodium hydroxide, how much lead 2 nitrate will I need? Guys, note the following. You do not have to do this. This is option, let's say option 1, and this is option 2. You do not have to do this. You do not have to do this. You have to do one of the two, either one. So if you do this, guys, same story. You have to end up doing a cross product here. And then when you solve that, you get that the amount of mole needed to use up 0,9 is going to be 0,45 mole of lead, but we actually got 0,6, so we have more than enough. We get the same answer. We have that sodium hydroxide is the limiting reagent. That's all the story. So now we know which one is the limiting reagent in this question. And then we are going now to get the theoretical yield. Now, theoretical yield in this case is a theoretical yield of the lead 2 hydroxide. So they want to know how much of the sodium lead 2 hydroxide, this one here, how much that one in grams is being produced? That is the question. Mass of the lead 2 hydroxide. That is the question. Now, to do this one, remember, if the question started just from there, all we have to do is always to find out the limiting reagent first. We know sodium hydroxide, so we are going to work, guys, with sodium hydroxide. So we are going to work with these two people here. We're going to work with those two, which in actual fact will need the ratio. Remember, the ratios are the numbers at the front. So to answer question B, all we have to do is to use the ratio of sodium hydroxide. Why sodium hydroxide? Because sodium hydroxide is the limiting reagent. So ratio of sodium hydroxide to lead 2 hydroxide. That is the question. So it's Pb bracket OH2. We have the ratio here in the equation. It is 2:1. Okay, I spoke about the ratio, so I'm not going to repeat myself. So it's 2:1. Now, how much sodium hydroxide do we actually have in this equation? We have 0.9. This is the amount we have. We cannot use the amount of lead 2 nitrate because we have more than enough, so it will be extras. We have to use the one that is going to finish first. So we go there and it is 0.9. Therefore, how much mole of lead 2 hydroxide will I get here? When you calculate the number of mole of lead 2 hydroxide, this is equal to 0.9. Let's fix that one. 0.9 divided by 2, guys. We get the number of mole is 0.45 mole. And all we have to do is to calculate the mass of lead 2 hydroxide. That's all we have to do. How we doing that? We go to the mass, or the number of mole equal to mass divided by molar mass. Obvious, we need the molar mass. Let's do the molar mass real fast for lead 2 hydroxide here. And if we do that, molar mass is going to be equal to 207 plus 2. Remember, the 2 is for everything, so it's 2 times 16 plus 2 times 1. And then you get that the molar mass is going to be 241 grams per mole. There we go. So all we have to do now is to calculate the mass. So if we substitute in the formula, we have that it is going to be 0.45 equal to mass divided by the molar mass, which is 241. The mass is going to be equal to 108.45 grams. And guys, this is the maximum amount of the lead 2 hydroxide we can actually get. This one is called the theoretical yield. In theory, we can get this amount here. This is what we call theoretical yield. That is the theoretical yield. Guys, we are done with this question. I hope it helped. It's a very good question to practice for the exams. It is a good question for exams. Thumb up, subscribe for the channel, send messages if you will. So I'll see you next time, Mr. G.